Okay, so these last two slides are kind of a transition into 7.4, which we are going to cover really briefly, which is plotting polar equations and what the graphs of your more common polar equations look like. So you're not going to often plot these things by hand, but I think it can be helpful to do so. Basically, we're just plugging and checking, right? You know, you're going to go through all the different angles and evaluate R for each of those, right? So if we say, okay, what's 1 minus cosine of 0, we get 1 minus 1, which is equal to 0, right? If we do 30 degrees, 1 minus cosine of 30 degrees is root 3 over 2, which is approximately 0.133, approximately. So we're here at the pole, and then we're just a little ways out. 45 degrees, 1 minus root 2 over 2, which we can throw in our calculator, right? 1 minus square root of 2 over 2. This is going to be about 0.29. So we go 45 degrees, and we're a little bit further. Root 60 degrees, 1 minus a half, which of course is a half. And so we'd be a little bit further out. And then 90 degrees, 1 minus 0, we're at 1. Right? 120 degrees, we would be 1 minus a negative, right, for a half. You can double check that, of course, with your calculator. So we would get 3 halves. So when we go to 60, we're at about 1.5, right? You do 135, so 1 plus root 2 over 2. That is going to be about 1.707. So we go 45, we say, well, let's eyeball it around there, right? 1 plus root 3 over 2. And of course, 180 would be 1 minus negative 1, which is 2. So we can go ahead and mark that one here. And so let's see, 1 plus cosine 150, that would be about 1.86. Yeah. So we're about here, right? So you can kind of see the pattern here. Now, when we go into 120, 225, so on and so forth, we are going to be seeing the same distance as we did in quadrant 2, right? Because cosine is negative in quadrant 3 as well as quadrant 2. So we're going to see basically, let's see, 30 degrees. So we're going to kind of see these going in opposite order. 1.5, let's see, 240. No, sorry, this would be 1.5. This would be the 1 plus root 2 over 2, which we said was about 1.707. So we can just kind of, you know what, I put that in the wrong place right there. That's better. 30 degrees, not 15. And so we can kind of, you know, eyeball these guys at, so it's 270, that would be 1 minus 0. And then we can do kind of basically the same thing at 300. 360, of course, is going to be 0 again. 330 is going to be about the 0.133, the 0.29, the 1/2 at 300. So that's kind of what we're looking at here. And I think I got that one off on the wrong line too. So we're looking, this is what's called a cardioid. Now we could have, because it kind of looks like a little, it looks like a heart, right? You do the 190, you're going to get back exactly the same value we got for 30. So these things are what we call periodic. They go around and generally and trace out the same shape over and over and over again. So here are some of our more common ones. We've got this infinity sign looking one that I think is called a lemniscate. Then we have these two sine 2 theta, cosine 5 theta. These are what are called roses. And then we've got Archimedes spiral, which is just a spiral, right? So I'm just going to write spiral because we'll do more of these very, very quickly in 10.4, which I am going to put on video for you guys. So that's it for this one.